Today, we are here at Ghent University to see this pyrolysis experimental unit that was built for the Syschemiq project. This unit converts plastic waste into pyrolysis oil that can be used as raw material for the production of circular plastics.
This means that you will heat up, in this case, the plastic waste. And this unit has all the elements of really an industrial plant. So the starting point is an extruder. An extruder, you really push the plastics and you make it into a liquid. Then it's fed to the reactor. In the reactor, you increase the temperature to 400, 500, or 600 degrees Celsius. And then you have basically the knockout section. There we are able to collect the liquids. The gas is basically entrained, is sent to the flare, but is also measured, quantified, and also the composition is determined. And in the end, we will disconnect all the elements and we will be able to collect the char, which will remain in the reactor.
In Syschemiq Work Package 3, we sort and pre-treat plastic waste as feedstock for two complementary recycling routes, mechanical recycling and chemical recycling via pyrolysis. In pyrolysis, it is still challenging to fully understand how plastics composition, but especially how contaminants present in plastic waste affect the quality of pyrolysis oil. That's why we have joined forces with Ghent University, Maastricht University and SABIC to build this pyrolysis experimental unit. Experimental data coming from this unit will be used to build a recycling quality model, what we call the RQ-Chem model, which quantifies the quality of plastic waste streams going to chemical recycling, telling us which streams are more suitable or less suitable for pyrolysis.
And with this unit, we can really track how much liquid is formed, how much gas is formed, how much solids, but also the impurities. And that's really the key element of this unit. We're able to track the impurities, chlorine, bromine, but also the metals.
This unit was inspired by modern thermopyrolysis systems both at bench and industrial scale. We tried to design this unit to be continuous, flexible, and well-controlled. We did it in a way that we can do the pre-treatment while feeding the plastics, but also really easily change the key parameters in the reactors.
The first part is the extruder, so we'll feed this real plastic waste to the reactor through this extruder from hopper. We'll heat the plastic to a certain temperature to melt it. The melted plastic will be pyrolyzed in this reactor, and the product will enter the 3 stages condensers. The first one will condense the high boiling point products, and it will enter the first collection vessel. And the second one will condense the lower boiling point products, and it will enter the second one. And if we still have some remaining products, it will be condensed in the last one. And the permanent gas product will be analyzed by this gas analyzer. So as you can see, this is the product we collect from the collection vessels. And you can see this kind of plastic oil. So this product we can use for the raw material for the plastic production.
I think the exceptional thing about this unit that is like plug and play. So we started it up and it worked. And with some minor modifications, we basically are able almost immediately provide data which are extremely valuable for the project. The unique features is that we can feed any type of plastic waste, the capability to measure really the impurities. That is, for me, groundbreaking. We're able to produce large amounts of liquids. And this is not only important for the analytical part, that we can characterize them, but also what to do next. The key question is, can we use the liquids as they are? Do we need to upgrade them? Or can we sort better? If we can sort better, then basically we might not need upgrading. And I think this unit will allow us to really understand this topic, and hopefully we can avoid upgrading of these pyrolysis oils. This is what we need for industry to really make decisions that are economically viable, and also to make decisions where to put plants, which waste to accept, and what upgrading is needed. So for me, the key value is data, but in combination with the models that will be developed in our project.
This unit is fundamental for the Syschemiq project to understand the cause-effect relationship between plastic waste and pyrolysis oil quality. This is important to make the best choice on sorting and pretreatment steps needed to pretreat plastic waste, but this also helps us to secure the quality of pyrolysis oil, which makes integration easier with existing petrochemical assets. This is a great example on how academia and industry collaborate with European funding to bridge the knowledge gap in plastic circularity.